Hi ladies, this is lesson 5.8. This is part 2. This is the story problem example. So we're going to look at a word problem that deals with maximizing volume. And in this particular example, we're looking at volume of a box. So if you just take a second, I'm not going to read it aloud, take a second to read through this problem. So we want to have the greatest volume possible. So that means that we need to maximize our volume. Now, if you think of what our volume looks like for this kind of problem, it's going to be, we're looking at the volume of a box. So we're going to take this piece of cardboard, we're going to cut little slits in it so that we can fold it into a box shape. And we're going to figure out how far we have to cut in order to give the box its largest volume. So first of all, let's think of what volume is. Volume is length times width times height. Now let's look at the volume of the box. We have this rectangular piece of cardboard, and the width, we'll call this the width, and we'll call this the length. Now, if you look at this width of the cardboard is 16 inches, but we're not looking for the width of the cardboard because we're looking for the width of the box. So the width of the box actually is only going to be this long. So the width of our box is actually going to be 16 minus this x on the top. And minus this x on the bottom. Because again, we're going to cut those pieces out so that we can fold our box up. So our width is actually going to be 16 minus 2x. Same idea with the length. It's not going to be this whole 20 inches. We're going to cut out x inches here, and we're going to cut out x inches here. So the length of our box is going to be 20 minus 2x. And then lastly, the height of our box. This is going to be our height right here. And that actually is going to be the value of x. All right, so now let's look at the question. How long should we make our cuts? That's us solving for x at the maximum volume. What's the maximum volume? So we'll have to find the maximum volume. And then what are the dimensions of the finished box? So before we do any of this, we need to write this as a polynomial function. Right now, we have volume equals 16 minus 2x, 20 minus 2x, and x. So let's actually multiply this out so that we can write it as a polynomial function. And it'll be to the third degree. So volume is 16 times 20, which is 320. And 16 times negative 2, which is negative 32x, minus 40x, plus 4x squared. And that's all times x. So let's simplify this volume function. And I'm just going to simplify it and write it in standard form. So that's 4x squared minus 72x plus 320, all times x, which is 4x cubed minus 72x squared plus 320x. So now that we have our polynomial function, we can plug this value into our calculator. So in your y equals plug this function in. From there, we can use our graphing calculator to find the maximum of our volume function. So you're going to have to adjust your window. Here's the window settings that I used. So you can pause the video while you adjust your calculator for this. And then I'm in a graph. All right, so here's what my graph of this function looks like. Now I'm looking to maximize volume. So I want to focus on this point right here. This is my maximum volume. Okay, now it's my local maximum. It's not the maximum of the whole function, again, but it's my local maximum, and that's the point I'm going to focus on. So if I were to just estimate what my x value would be at this local maximum, let's just look. So right here, it looks like it's about 3 inches. So if each one of these, the scale is set to 1 still on my graph. So if each of those is 1 inch, it looks like my x value is going to be about 3 inches. Now you can't really see my scale here for my y values, but whatever this coordinate is, whatever this y value is right here, that's going to be my volume. All right, so let's look at our graphing calculator, and let's actually calculate our maximum. So second, calc, we're looking for maximum, that's number 4. It asks us left bound, so scroll to the left of your maximum, scroll to the right of your maximum, and hit enter. All right, so this tells me what my maximum is. My maximum is 420. That means my maximum volume is 420.11 cubic inches. When my y value is 420 cubic inches, so that means this is 420 right here, what does my x have to be? So again, my estimate was 3, but it actually looks like it's a little under 3. So my x is 2.94. And then lastly, it asks me my dimensions. So if my length was 20 minus 2x, minus 2 times 2.94 is 14.12 inches. My width is 16 minus 2x. So if I plug in 2.94 for my x value, I get a width of 10.12 inches. And then lastly, my height was x, which is 2.94 inches. So please jot down any questions that you have about this problem, and we can go over them one-on-one or next time I see you in class. Thank you.